individual modules doesn't quite cut it. We need to have a way of collecting together related modules. And this is done in Python by using the Python package. And actually you've been using Python packages already. So things like NumPy and Matplotlib are examples of Python packages. And we can see what happens if we look at the dunder file special variable that you've got in NumPy. So remember the dunder file special variable we looked at in the previous part, that gives you the file name of where the module is. So what happens when we do that with NumPy and we ask it for its file, then you see what it's telling us is it's actually inside a file that's called __init__.py, and that file lives inside a directory, a folder called NumPy. Well, remember again, every time we see an __, you want to be thinking, that's probably something to do with the internals of Python. And if Python has a directory which contains an __init__.py file, then Python will understand that that directory is a Python package whose name is given by that by that directory name. If you look on the disk inside that directory, then you'll see that there are several module files, so several .py files in there. So inside NumPy, for example, I think there's normally a module called ctypes.py, and there will also be folders which themselves contain dunder init.py files, __init__. So for an example would be the FFT directory, which contains a fast Fourier transform package. So there are packages and sub-packages, and you can have sub-packages and so on. And you'll see this and you'll be using these. So if you read, say, the NumPy documentation, it'll maybe tell you that you can get something is in numpy.fft. So you do from numpy.fft import something or other. That translates to Python. It sees the dot in the name of the module and says, the first part is the package, and the next part is either the module or the sub-package I need to load from. So when you're actually importing the NumPy package, what it's actually doing is running all the code that's in the __init__.py file. And that's the thing it's really importing, and that's the thing whose results it puts in sys.modules. So if that dunder init file itself starts importing a bunch of things, then those become things that are available within the package. So for example, in this case, the dunder init file in NumPy will import ctypes and import FFT, and then that means that becomes available to your program as numpy.ctypes and numpy.fft. So it's able to build together and reference a whole collection of different modules under a root, under a common root, which is the package. And then the submodules of the package potentially also have their own names within sys.modules. It depends on exactly how you've imported them. So and often in many cases there's some trickery going on, and NumPy is a good example of this, that actually NumPy won't import all of the submodules until you try using them. So if you just import NumPy, then you won't find numpy.fft is in sys.modules, but as soon as you try referring to numpy.fft, then it exists within sys.modules. So there can be a little bit of fun things like that going on. But the main thing to take away from this is just an appreciation that just as a Python module is just a simple file that contains a Python code, a Python package is a collection of modules and is just a directory that contains Python files, or with a .py extension.